Hello and welcome to Cerulean Canvas. In this video, it's time to focus on Docker images. As we have seen previously, a Docker image is a collection or stack of layers which are created from sequential instructions on a Docker file. The layers are read-only, although there is an exception of the topmost layer which is read-write type, but we will get into that later. The Docker images can be recognized either by their unique image ID, which is provided by Docker, or a convenient name or tag, which is provided by us, means users. Finally, they can be pushed or pulled from Docker Hub, which we just visited in the last demo. If we want to visualize the layers of a Docker image, they would stack up like this. We start with the boot file system, which is pretty much similar to Linux's own boot file system. It is an arrangement of cgroup, namespaces, and resource allocation, which virtually separates the image from rest of the files on the host or cloud. On top of that, we would have base image layer, which along with the layers above it will follow the file mapping laid out by boot file system layer. Next, we have layers such as work directory, environmental variables, add, copy, expose, cmd, etc. Speaking of intermediate images, here are a few points to remember. First of all, as we have mentioned earlier, intermediate images are created out of individual Dockerfile instructions, and they act as layers of main image or resultant image. All of these intermediate images are read-only, so once the image is built, these layers will not accept any change whatsoever. They have separate image ID of their own, which can be viewed using Docker history command. If you are wondering why does Docker have existence of intermediate images in the first place, it is for caching. For example, if you are building two different images from the same base image like Nginx and Apache on top of Ubuntu, the base image layer will only be downloaded once and will be reused when it is the same. To make this caching simpler, we have intermediate images where each layer has its own significant identity and it separates itself from all other layers in terms of usability. But the intermediate images may not be used on their own, since they would not be sufficient to run a container process by themselves. For example, even the smallest image would consist of at least one base image and one CMD or entry point instruction. Finally, they are stacked as a loosely collective read-only layer by AUFS, which is a union file system. Do you want to learn more about Container, Docker, and Kubernetes? Head over to the Container Masterclass on Udemy and get a whopping 89% discount. You will get concepts, quizzes, labs, case studies, and practice problems as well. Students love this course, and you can be one of them too. So what are you waiting for? Click on the link in the description below and the course is all yours. If you liked this video, give us a huge thumbs up, share, and subscribe. And don't forget to hit the bell icon so whenever we post a new video in this series or something else which is equally exciting, you will get an instant notification. This has been Cerulean Canvas and we'll see you next time. Till then, happy learning!